Ever wondered how razor blades, so sharp and precise, are made? What goes into creating that perfect edge? In this video, we'll take you behind the scenes to explore the fascinating process of how razor blades are made. From the raw material to the final, precision-cut edges, every detail matters when crafting these essential tools for personal grooming. Whether you're a fan of traditional shaving or simply curious about manufacturing, you'll be amazed at the intricate steps that go into making a blade that's both sharp and safe. How does steel transform into the sleek, sharp razor blade you use every day? Stick around to find out. Don't forget to like, share, and subscribe to our channel. Don't forget to hit the notification bell so you never miss any of our latest updates. Now let's dive into the amazing world of blade making. Razor blades are some of the sharpest and most efficient tools we use today. They are essential for tasks like shaving and hair removal, offering the precision and protection needed to avoid severe cuts and injuries. Razor blades have evolved tremendously over time. What began as primitive tools used by early humans has turned into highly engineered products designed to give us smooth and safe shaves. The journey from raw materials to finished products involves multiple steps, advanced technology, and sophisticated craftsmanship. But have you ever wondered exactly how razor blades are made? What goes into transforming a simple piece of metal into a razor-sharp cutting tool? Let's dive into the intricate process behind the manufacturing of razor blades. A brief history of razor blades. Shaving dates back over 30,000 years, with early humans using stones and shells as makeshift blades. Throughout ancient history, cultures developed various types of shaving tools. In Egypt, razors were made from materials like bronze and later iron. These were often used by priests and warriors as part of their daily rituals or to ensure they didn't have their beards pulled in battle. In Rome and Greece, shaving became a symbol of cleanliness and personal grooming. By the mid-19th century, barber shops began to emerge, and this marked a significant turning point in razor design, leading to the creation of the first two-piece razor blade with a reusable handle. However, it was King Camp Gillette who revolutionized the razor blade industry in the early 1900s. After experiencing the inconvenience and risk of traditional shaving tools, Gillette invented the modern razor blade, a single-use, disposable razor that was not only efficient, but economical. This invention solved a personal problem for Gillette, and over time it became an industry standard. Today, razor blades are essential tools in the personal care industry, with millions of people around the world shaving daily. The manufacturing of razor blades. The production of razor blades is an intricate process that involves several key stages. These stages are critical to ensuring that the final product has the durability, sharpness, and safety required for effective use. Razor blades are made from high-quality stainless steel, which provides the necessary toughness, corrosion resistance, and edge retention. Below is an in-depth breakdown of each step involved in making razor blades. Selecting the raw material. The process begins with the careful selection of raw materials. Razor blades are typically made from stainless steel, known for its strength, resistance to corrosion, and ability to maintain a sharp edge. The steel used in the manufacturing process is extremely thin, about 0.1 millimeters thick, but strong enough to hold its sharp edge throughout multiple uses. At the start of production, large sheets or strips of stainless steel are used. These strips are elongated, curved, and extremely thin, about 1/10 of a millimeter thick. This steel will form the foundation of the razor blade, and its properties will dictate the blade's performance. Stamping and preforming. The next step is stamping the stainless steel strips into the basic shape of the razor blade. A punching machine is used to stamp out the preforms, which are the raw shapes of the blades. At this stage, the steel remains soft and flexible, like paper. The stamped pieces are not yet sharp or hardened. They are just the basic template of what will become the razor blade. The preforms design is very important because it will determine the final shape, size, and functionality of the razor. These forms are then prepared for the crucial hardening process, which gives the blade its strength and sharpness. Heat treatment process. Once the preforms are stamped out, they undergo a 4-step heat treatment process that hardens and strengthens the metal. This is a crucial part of the blade-making process because it transforms the steel from a soft material into a hard, durable product. Step 1. Heating the preforms. The preforms are first heated to a temperature of about 1100 degrees Celsius for 30 seconds. This intense heat begins the process of transforming the metal at a molecular level. At this stage, the steel is malleable, which allows it to be reshaped and prepared for hardening. Step 2. Tempering. After the heating process, the preforms are cooled rapidly by being dipped into cold water. This rapid cooling process, known as tempering, is essential for ensuring the blade becomes strong but not brittle. The sudden temperature change causes the steel to contract, locking in the hardening process and preparing the blade for further refinement. Step 3. Extreme cold treatment. After the tempering stage, the preforms are exposed to even colder temperatures. They are placed in a cooling chamber where they are chilled to a temperature of 50 degrees below zero for about 20 seconds. This extreme cold further refines the steel's molecular structure, making it harder and stronger. Step 4. Reheating. The final heat treatment stage involves reheating the preforms for 20 seconds. This process helps to reduce the brittleness that results from extreme cold and ensures that the blade maintains its strength while retaining its flexibility. Branding and stamping. Once the preforms have undergone heat treatment and hardened, they move on to the next stage of production. Branding and stamping. This is where the manufacturer's logo or brand name is stamped onto the blade. This is done using a printer that applies wet ink to the blade, marking it with the company's identification. After the branding, the blades are passed through a gas flame to dry the ink instantly. This ensures that the branding is permanent and doesn't smudge during further processing. Grinding and sharpening. The next critical step in razor blade production is grinding and sharpening. This is where the preforms are transformed into sharp, cutting blades. The preforms are placed into a grinding machine that has 3 grinding wheels. These wheels shape the edges of the blade, creating the 2 sharp cutting edges that are essential for a close, smooth shave. The grinding process requires great precision. The contours of the blade must be finely shaped, and the cutting edges must be honed to perfection. It's also important that the grinding process is uniform, ensuring that every razor blade in the batch is just as sharp and durable as the next. Polishing and finishing. After the grinding process, the razor blades are transferred to a polishing machine, a crucial step in the production process. The purpose of this machine is to eliminate any burrs or rough edges that may have formed during the grinding phase. These burrs, which are tiny fragments of steel left on the blade, can compromise the smoothness and performance of the razor. Polishing ensures that the edges are perfectly smooth and free from imperfections, creating a refined, high-quality blade. In addition to removing burrs, the polishing process also helps to improve the surface finish of the blade. By gently buffing the steel, the machine enhances the blade's smoothness, reducing friction when the razor is used for shaving. A smoother blade glides effortlessly over the skin, providing a more comfortable and efficient shave with minimal irritation. During polishing, the blades are carefully separated from any parts that were still connected from earlier stages of manufacturing. Any remaining attachments or pieces that are not part of the final razor are removed. The blades are then meticulously cleaned to ensure no residue, metal shavings, or contaminants remain on the surface. This step is essential for ensuring that the blade is safe for use on the skin and meets the high standards expected of quality razor blades. Quality control. Quality control is an essential part of razor blade production. At this stage, a team of technicians inspects every blade to ensure that it meets all the required specifications. Samples are taken from each batch, and various aspects of the grinding, sharpness, and cutting-edge angle are tested. The technicians use fluorescent lighting to examine the blades closely, looking for any defects that might not be visible under normal light. Any blade that is found to have a defect is removed from the batch and discarded. Once a batch passes the initial quality control checks, the blades are washed with a solvent to remove any oils, dirt, or contaminants from the manufacturing process. After they are cleaned, they are dried thoroughly to ensure that they are ready for the next stage. Coating and chrome plating. To further improve the blade's performance, a chrome-based coating is applied. This coating helps enhance the blade's hardness and resistance to wear and corrosion. The application of the coating also improves the blade's glide over the skin, making the shaving experience smoother and more comfortable. The blades are sprayed with a fine coating and then baked at a temperature of 350 degrees Celsius for 20 minutes. Final testing and durability checks. After the coating process, the blades undergo one final round of quality control. Technicians measure the strength of the blade by testing its ability to cut through a thick bundle of wet paper. This test ensures that the blade meets the required strength and sharpness specifications. Another key test involves checking the blade's cutting ability after it has been coated. The coated blades are then tested to ensure they retain their sharpness and cutting performance even after the coating process. Submersion in organic oil. To enhance the protection and longevity of razor blades, they are immersed in organic oil for approximately 30 minutes. This oil serves as a vital safeguard against corrosion, ensuring that the blades remain in pristine condition during storage and transportation. By forming a thin, protective layer over the surface, the oil prevents moisture and air from coming into direct contact with the steel, which could otherwise lead to rusting or degradation. This coating significantly extends the shelf life of the blades, keeping them sharp and ready for use when needed. The organic oil also plays a crucial role in preserving the sharpness of the blade. The oil's consistent coating helps reduce friction between the blade and its surroundings, preventing any dulling effects that might occur from exposure to environmental elements. It effectively keeps the razor's cutting edge in prime condition, allowing it to retain its sharpness over time. This protection is essential as the razor blade needs to maintain its precision for multiple shaves. By using organic oil, manufacturers not only enhance the blade's durability, but also add an eco-friendly element to the production process. The oil is biodegradable and safe for the environment, offering an additional layer of sustainability to the manufacturing method. Packaging and distribution. Once all the quality checks are complete, the blades are individually wrapped in wax paper. This protective paper helps prevent corrosion during storage and keeps the blades sharp until they are used. The wax paper is strong enough to protect the blade from damage, but not so thick that it interferes with the blade's sharpness. After the wrapping process, the blades are packaged into cartons and prepared for distribution. These packages are sent to stores and retailers around the world, ready for consumers to purchase. The process of making razor blades is a fascinating blend of tradition and technology. Razor blades are crafted with extreme precision and care, ensuring that they provide consumers with the sharpest, most durable shaving tools available. The steps in the manufacturing process, from selecting the raw material to the final coating, are critical in ensuring that each razor blade meets high standards of performance and safety. Through years of refinement, razor blade manufacturers have perfected the art of creating the perfect blade. Every detail from the steel composition to the final testing ensures that consumers receive a high-quality product every time they buy a razor. The manufacturing process behind razor blades is a testament to the importance of craftsmanship, innovation, and quality control, making the modern razor blade one of the most sophisticated tools in the personal care industry today. If you enjoyed this video, make sure to give it a thumbs up, share it with others, and subscribe for more fascinating insights into everyday products.